For our last portion of the sample problem, we're going to be doing a major excavation for a basement foundation. So we're leaving Plan 100 as is, but it is going to need some additional information. So as the bullet points show, if the major excavation extends 2 feet beyond the foundation wall dimensions, not footers, the walls, the angle of repose is 40 degrees. Depth of excavation to the bottom of the 4-inch slab. Footers will be excavated by hand. No existing grade is provided, therefore use finished grade and dimensions. We have a swell factor of 20% and a shrinkage factor of 90. So if we look at our section cut again and look from front to back, we will see that we were going to the bottom of the slab, which if you look at your wall section detail sits on top of the footer. So therefore excavation is going down to the top of the footer. It is only including the wall height, not our footers. Those will be excavated by hand. We put some numbers to it. We see that again our outside to outside foundation wall is our full 36-foot length. We can calculate, we have our workspace, our unknown, additional ones we need to calculate. If we cut front to back, look left, it does not matter that we have 2 different footers. We have our, it does not matter that we have 2 different footers because it goes to the top of our footer. And again, we have our calculations, our numbers, everything that we need to calculate. What is going to be consistent here is that we have our 8 inches from the top of foundation wall to grade. So again, that will come into play in all of our calculations. The problems we are going to be working on, we need to calculate the depth of the excavation, the volume of the foundation system below grade, the volume of soil to be excavated for the major excavation, the volume of soil to be taken back for backfill. Once we have those numbers, we can then figure out our loose cubic yardage of haul and borrow for backfill. So starting off with problem number 12, we are looking at our depth of excavation. So just like with our trench, we need to know our wall height, which is still going to be our 8 feet. And we need our top of wall to grade, which is our 8 inches. Because we are only excavating to the top of the footers or the bottom of the slab, we don't need to know what our footer height is. So our excavation depth or excavation height, whichever way you want to call it, is simply going to be the 8 feet that is our wall minus that 8 inches of top of wall to grade. So 7'4" is what we have for our depth of excavation. Number 13 is the volume of foundation system below grade. And while number 8 is where we calculate this in the trench example, and we had to do a lot of steps to figure out the volume of the walls and the footer, it's actually a lot easier when we're doing our basement excavation, because it's essentially just a really big cube that we have to calculate. All of the foundation system that is between the walls of our basement, so everything in here will not be backfilled. That is considered foundation system below grade. So we're just looking at one big large cube that we're calculating, and it's based upon the walls, not the center line. So we have our length of 36 feet. We have our width of 26'4". The only thing you have to be careful of, the height, is still going to be the depth of the excavation. It's not the height of the wall. So we have 6,952 cubic feet. Convert it into cubic yards. And we have 257.4815. So 257 cubic yards. While the volume of foundation system below grade is easier to calculate, the volume of soil to be excavated for major excavation actually is the little bit longer problem. So with a trench, we used center line for our length, average width, and then the depth of the excavation. With a basement, our length is actually going to be a variation of the average width calculation, and we're going to find an average length. The width will be an average width, but it is calculated a little bit slightly different than the trench, and then our height is still going to be our excavation height or excavation depth. So when we are looking at our average length and average width here, we still need to know what our workspace is. We still need to know that unknown, but what we'll do is we'll throw in our actual length of our foundation wall and actual width of our foundation wall, not the footer dimensions. So our average length we need to have our 36 feet is what we'll use instead of our footer, plus 2 times our workspace, and here it's 2 feet, but remember 2 times 2 feet, 1 on either side, and that's beyond our foundation wall, so we don't have to do any special calculations for that, plus our unknown, and this is calculated by taking our height, so our excavation height divided by the tangent of our angle of repose. In this sample problem, it is 40. Our average width becomes the same calculation as average length. We're just substituting out the 26'4" width instead of the 36' length. 2 times 2 feet for each of our workspace, 7'4" divided by tangent of 40 degrees. So our excavation height is still the 7'4". If we then calculate our volume, it is our length times width times height. Plug these numbers in. So what that means is calculate all of this, plug it into our length, calculate your average width, plug it in for your width, and then just bring down your 7'4" for your height. We do all that, run through our numbers, we get 13,965.4897 cubic feet. Divide by 27 cubic feet per cubic yard. 517.2404, 517 cubic yards. So as long as you can keep it straight, keep your numbers correct, you'll be fine. Figuring out backfill, same as before, very simple. We take our answer, in this case from number 14, which was our excavation, minus what we calculated number 13, which was our foundation system below grade, 517.2404 minus 257.4815, 259.7589. So roughly 260 cubic yards. And again, the last two are calculating our loose cubic yardage first to be hauled away from the job site. So that is based upon the excavation number that we calculated in number 14. So the 517.2404 times 1 plus our swell factor. It is changed for this problem. So we have 620.75 0.6885, so 621 cubic yards, or you can again write it loose cubic yards, that's fine. And 17, this answer comes from number 15. We take our 259.7589. We divide that by our 0.9 shrinkage factor, and then multiply that by 1 plus our swell factor. $343.3087, or 343 cubic yards. And that is how you calculate the major excavation. And here we can see that we're hauling away 621 cubic yards. We only are backfilling 343. Very common with basement excavations is you don't haul away, or you don't need more back than you haul away like you do with trench excavations, because that whole center section of the basement is not needed. 2 additional drawings that are posted to Blackboard for your reference are general plan view and section view for trench excavation for crawl or slab on grade. Again, crawl can be either major excavation or trench. For here, we're going to lump it in with slab on grade trench excavations. But the main thing to know the difference of is that the trench goes all the way around the foundation wall, and each one are labeled differently. And then with a basement, everything in the middle is taken out, so those aren't included. So we do not use centerline for basement excavations. We use an average length, an average width, and a height. With trench excavation, we use centerline, perimeter, average width, and the height of the excavation. The only thing that stays the same between the two are the height of the excavation. Average width is even calculated just slightly differently, because average width for a basement includes the entire wall-to-wall width. Width for a trench is just the further width.